very quickly, yeah. All right, so I'm going to present my screen and get you guys going on the warm-up. Oh, you know what? I didn't even open the warm-up. Give me 1 minute. I got to get it open. It's loading. Hold up. Me?
Yeah.
No, this is where the warm-ups are.
Did you have them last year too?
Yeah. Oh, wait. Hold on. This one. Okay, there's your warm-up. It's only 4 questions, and honestly, I think it'll take you like 2 minutes tops, but I'm going to leave it up for a few minutes so that people can get logged in from home. But number 1, which letter is at the point 3, 5? So where is that? And then number 2, which letter indicates the point -8, -7? And then tell me the ordered pairs for H and D. Okay? So go ahead and be working on those. Again, I know that it probably won't take you very long. So when you're done, just sit tight, draw me a pretty picture on your whiteboard or something. Okay. Sorry. I know. So I'm just checking. Go ahead and get working on that, please. Yeah. Yeah, go ahead and join the meet if you can't see, that's fine. Again, just make sure your microphone's off so that it's not, yeah. Yoshi, how charged is your computer? Are you good to move back to your desk for this lesson? Okay, can you do that, please? Yeah, you're probably fine. Over lunch, we can get it charged.
I'm done, Ms. Jones.
All right, draw me a picture on your whiteboard.
Look, guys, 22. What? Where? What's 22? Degrees over here. Can I ask her when Charlie gets back?
Yeah.
After Dallas.
Sure. Hey, Lonnie, we're just working on our warm-up for a few more minutes, so go ahead and be working on that. Same with you, Felicia, just working on our warm-up, please. Awesome, thanks.
I'm done.
All right, we're gonna give it a couple more minutes. I know that this is kind of a quick warm-up for you guys, but we're gonna give it a minute or two just to let people get logged in, and then we will review really quick. Okay, so a couple more minutes. About 2 more minutes, and then we will review it. And then I don't think that our lesson will be very long today. No, we're going to do something more than just the warm-up. Just a little bit of notes, yeah. But they're a little bit better than yesterday, more to the point, less words, more you guys actually trying the problems. So, yeah. I'm tired, guys. I'd like to take a nap.
Please, I don't know what the heck.
Alrighty, about 1 more minute on this warm up. Quickly. All right, let's go ahead and review this. So I'm going to close out of it and just type directly on the screen. Let's do 50 is fine. So number 1 says, which letter indicates the point located at 3, 5? What would that be? What point? C. So if we start at 0, 0, it means that we need to go to the right 3. So 1, 2, 3, and then up 5. 1, 2, 3, 4, 5, which is the point C. Good. What about -8, -7? Where's that at? Point B? That is correct. Point B, that means that we start at 0, 0, right in the middle.
What do you mean, where is that at? You mean, like, what is that?
I mean, both work.
It's like, that is the word that is that. The B is, what is that?
Yes, sure. To get there, though, we would start at 0, 0, right in the middle. What is 0, 0 called? What's the name of that?
Origin.
The origin. We would go backwards 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then down 7, which would put you at the letter B.
B.
All right. Number 3 here. Where is H located? So first we have to find it. What quadrant is H in? What quadrant?
One.
It's quadrant 1. Quadrant 1 is the top one right here. Quadrant 2 is the one on the left. Quadrant 3 is the one on the bottom left. And quadrant 4 is on the right. So H is in quadrant 1. What is the ordered pair for it, though? 4, 2. Good. You go to the right 4, up 2. Good. Now, what about point D? Where is that? What quadrant first?
4.
Quadrant 4.
Quadrant 4.
Good. Quadrant 4. The bottom right one. Now we need to figure out what the ordered pair is. How many, or what is it?
7, -4.
I got 2 answers there.
6 and -4.
That's a third answer. So a lot of you guys said the -4. The -4 is correct. But it's in between 6 and 8. What number is in between?
7.
Good. +7 down 4. So 7, -4. Okay. And there's our warm up for the day. That's our warm up. We're gonna be plotting a lot of points today, so I wanted to just kind of review that really quick. I'm gonna go ahead and get rid of that.
We should do Jeopardy in this one.
Maybe Mrs. Ellis said that she found a cool game, so maybe later in the week we can work to do that. Or maybe
Quizzes today?
say that again.
Are we doing quizzes?
No, no quizzes today. So over in Google Classroom under math, let's see. It has not been posted, so I'm gonna go make it post. We did our warm up a lot quicker than I thought we would. So I'm gonna get it going. There it goes. Okay, go ahead and reload your Google Classroom, and it should be called Missing Vertex Practice. So go ahead and get that open. I'm going to check attendance while you guys do that really quick. You might need to shut your computer down then and restart it. Yes. Yes, we will be typing on this one. Okay. So we're going to go ahead and get this opened up on your screen. Everybody needs to have it open. You will be typing on it today, so you want to make sure you have it opened.
There are 13 slides. Are we typing on all of them?
No, not on all of them. It's like every other slide.
So we'll do, oh, yeah, I see, yes, I do that.
I want to say there's 5 or 6 problems that we'll do together. Yep. No, just in general. We're going to do most of this together. Tomorrow's stuff, you might do a little bit more on your own. But today we're going to practice, because yesterday wasn't really that great of a lesson. I'm not going to lie. I was not happy with how yesterday's math went. So today we're going to do a lot of it together just to practice.
Do we have to turn the assignment in from yesterday?
No, you don't have to, but you can.
Oh.
Okay.
I turned it in.
That's fine. All right. So for today's Google Slides, it says to use graph paper. We don't have graph paper. Well, I mean, I do have graph paper, but we're not going to do it on graph paper. But every other slide has a coordinate plane for us to do it on anyway, so we'll be fine. We don't have to draw our own graphs. They're already there for us. So if we are on slide number 2, we're basically just going to do some practice problems together. I'm going to get zoomed in. 50 is pretty good. Number 1 says, if the points 1, 1, -3, 1, and -3, -2 are on a coordinate plane, and they're vertices of a rectangle, what are the coordinates of the 4th vertex? So before we even start, what's a vertice on a shape, a vertex? Not the angle, just the corner, the points.
Corners.
Good, it's the corners. So in slide number 3, we're going to plot those points. I'm going to...
Do we have to use the dots?
Yes. Let me finish talking. So it says, based on the question from the previous slide, so we'll look at slide number 2 and use those coordinate points. We're going to move the dots to the correct spots. So our first one is 1, 1. So these dots can move, so we're going to put them in the correct spots. How do I get to 1, 1?
Just go to like that.
So we're at 0, 0. What am I going to do?
Quadrant 3.
What?
Does the dot go in quadrant 3?
Not in quadrant 3. It'll be in quadrant 1 on this one.
And then you just put the dot like that.
So we go to the right one, up 1.
Yeah.
Okay, so there's 1, 1. Well, no, guys, we're trying to make a rectangle, but we have to figure out where the 4th one goes. We don't have a 4th one.
I know. Now you got a -3.
Okay, so our second ordered pair is -3, -1. Let's go through the problem instead of skipping ahead, please. -3, -1. Oh, wait, sorry, -3, +1 means we're going to go backwards 3 to the left and then up 1. So notice that these two are on the same line, right? This would be the top of our rectangle that we're trying to draw. Our last point goes where?
So go to negative, so go back to -3, and then go down 2.
Good. We started 0, 0, and our order pair is -3, -2. So we go backwards 3 and down 2. And that's it directly in line with the other one. So this is the side of our rectangle. Now, if we're trying to draw a rectangle, we're missing the 4th vertex, the 4th corner. How am I going to find that?
I know.
Charlie?
Here were two dots made up, which is
Good.
1, -2.
Good. So we're going to figure out where these two dots would meet up. So if we had a piece of paper, we would draw it out. But I'm just going to draw a oh, that's a terrible line. But so I have a line right there. Wow, it's really faint. Hang on. Let me make it bigger. So there's part of a line, right? And then we can draw the other one straight down from it. I'm going to make that a little bit thicker too. And then wherever our lines cross is where that 4th vertex is going to be.
Do we need to draw that line?
No, you do not need to draw the lines. It's just, I just want to show you guys how to find it. We don't have a 4th circle here, so we're going to need to copy and paste one. So yeah, right click on it, copy. Oops, whoa. Paste. There's an extra dot. Sorry, I didn't make enough dots. And we need to figure out where this ordered pair goes, or this dot. We know that it,
So go put one.
yeah, we know that it needs to go where those two lines intersect. So we put it on this spot right here.
Do we have to do the extra dot?
Yes, we need all 4 dots at the end, yeah. Click on the first dot and then right click, or if you're on your Chromebook, you can like double tap with 2 fingers, right? So right click on it, do copy and then paste.
Or you just go find a black dot.
Yeah, that too. Or you can draw the shape if you feel like it. Okay, so the only thing we need to do left is up on this line right here, we need to write the ordered pair. It's kind of small, but up at the top, we need to write the ordered pair of that 4th vertex.
So
Where is that 4th dot at that we put?
it's gonna be 1 and then -2.
Good. Over 1, so +1, and then down 2, -2. I'm going to make my box a little bit bigger so that it fits. There we go. So our answer here, I'm going to bold it so you guys can see our final answer. That did not get very bold, did it? I'll highlight it. How about that?
There, I did it.
There we go. Our final answer here is that our 4th vertex, the 4th corner of our rectangle, goes at the ordered pair 1, -2. So when it says find the missing vertex, it means find the missing corner. Do you guys see how we have done that here? Found the last corner? Okay.
Yeah, you just have to line it up with the bottom one, and you have to line it up with the top.
Yep, it's just a lot of lining things up and making sure that they intersect.
Are you always making a rectangle on them?
Nope, not always. We'll do a couple of different ones. It might be a square. It might talk about a triangle. So we'll talk about a couple of different problems. Huh? Okay. All right. Are we ready for our next one? Huh? What? Yes. So on slide number 4, this one says if the points -3, 1, -3, -1, and -1, 1 are on a coordinate plane, and those are the vertices of a triangle, what's the length of its legs? So I want you guys to go and plot the points on the next slide.
Go for it. Actually, we'll be right back. And plot the points on the next one, please. Okay.
Okay, those of you online, I need to watch Mrs. Stacy's class for a second. So just on this slide, plot those 3 points to make that triangle. Okay, so take your time and make that triangle. I'll be back.
It's a triangle?
It will be a triangle this time. We're going to talk about it in a triangle.
Oh, a triangle everywhere.
Easy peasy, lemon squeezer.
What is? I guess you ran away. Oh, did it? Did you go? Okay, there we go. Can you, it's like really, I'm gonna follow this one. Okay. It's like video for quick, so you got it all. Do we have to line them up?
Okay.
It'll make it well.
It's gonna make it we're gonna work with a triangle. We're not creating a rectangle this time. Because if you look at the question, it's asking you about the triangle this time.
I'm gonna do it because it kind of bugs me.
Leave it.
All right. Okay, Miss Stacy's back, so we can do this one. So let's go ahead and plot these points first. I think you guys hopefully had enough time to plot those points. Our first one is -3, +1. So we're going to take our dot and there we go. Start at 0, 0. -3, +1 means we're going to go backwards 3. 1, 2, 3. Up 1. So it goes about there. Did you guys get that one?
Yep.
Good, good. All right. Our next dot goes at -3, -1. So we start at 0, 0. We go backwards 3, down 1 this time. Okay. And then our last dot goes at
-1 and
-1, +1. So we go backwards 1, up 1.
wait, that's not what I did. That's what I did.
Yeah.
Yeah.
Backwards 1, up 1.
Oh, I did it here.
You flipped the ones and the -1. Yeah. So I'm just gonna draw the lines in really quick just so that we can see the triangle here. Okay, that was a terrible one. Undo. Hang on. Okay, so if we connect our dots on this one as best as you can. Wow, these are not going well this time. Hang on. Undo. Okay, that's as good as it's gonna get. So we have this triangle. I'm gonna redo this one. Okay, it's good enough. No, it's not good enough. It's just not drawing them very well.
Do we have to draw the lines?
No, I just wanted to for this. So we have our triangle here. The question that it is asking you is to find the length of one leg of the triangle. When you're looking at this triangle, the legs are the ones that come off of the right angle. So it's these two, not the long diagonal one. Yes. It's actually not, but you'll learn about that in like 7th and 8th grade. Yeah, but it's probably not. We'll learn about it later. Promise. So on these ones, we need to find the length of these legs. We know how to find the distance between 2 points. What can we do? Don't overthink it. How can we find the distance from this dot to this dot? You can count. You can count the squares. So if we start here, it counts 1, 2. The length of one side is 2 units. That's it. That's our answer, 2 units. Yeah, because the distance from this dot to this dot, the leg of a triangle of this one is only 2 units on this. 2 units. There's our answer. I'll give you guys a minute to go ahead and type that out. All right, let's look at our next one here. Slide number 6 says, if the points 1, 1, 4, -3, and 0, -3 are in a coordinate plane, then they're the vertices of a triangle. So we're drawing another triangle. What is the length of the height of the triangle? So we need to go plot these points again. So on slide number 7, let's do that. We have to plot the point 1, 1. Huh. Okay, that's fine. Then just wait for us to catch up. So 1, 1 means we're going to go over 1, up 1. Then we've got 4, -3. So that means we start at 0, 0. We go a positive 4.
Is this a rectangle or a triangle?
Read the question again, and it'll tell you.
Triangle.
Yep, so over 4, down 3. And then this last one, we start at 0, 0.
There's 2 slides on this one.
0, -3 means we stay at 0 and we go down 3. Okay, this time we have kind of an unequal looking triangle, right? Okay,
So, nice.
I'm going to draw the lines in again just so that you guys can see our triangle here. No. All right, so we have our triangle here. Now, when it talks about finding the height of a triangle, where do you find the height? How do you find the height of a triangle? Is it the length of a side? Not the length of a side. When you look for the height of a triangle, it goes from the top point, the tippy top one, straight down to the base of the triangle. So it's through the middle of the triangle. Let's make this like a dotted line. Okay, so it starts at the tippy top right here and goes down to the base of your triangle. And then it's asking us to figure out how tall this triangle is. How can I figure out the height of this triangle? What could I do? Count the squares. Start at the tippy top of your triangle and count to the bottom. So we have a 1, 2, 3, 4. So how tall is this triangle? 4 units. And that's our answer. I'm going to go ahead and highlight our answer on this one. Give you guys a second to get that typed out. Okay. How are we doing? Is this making a little bit of sense, what we're doing? Not too difficult? Good.
No.
It's hard to get open.
Good. Okay. Ready for our next one?
I'm ready.
All right, let's go ahead and move on to our next one. So slide number 8 says, if the coordinates of 2 vertices of a square are 0, 0, and -3, -3, tell what the other coordinates will be. So this time we're making a square. So let's go ahead and go on to our next one. We are going to need 2 more dots, so I'm just going to quickly copy and paste 2 more dots because we're going to need 4 total. So that we have 4 dots. Because we're making a square, so we need to have 4 corners. And then we need to plot 2 points for 2 of the corners. So let's start with 0, 0. Where is 0, 0?
The middle.
Good. Directly in the center is 0, 0. Perfect. Then we have the ordered pair -3, -3. We start at 0, 0, and we need to go left 3 to -3, and then down 3.
Let's go ahead and start getting ready.
Okay. So we have this like diagonal line. Does it make sense for, I mean, you can have a diagonal square, but that kind of makes it a diamond. So in order to find these other vertices, I'm going to draw some lines, and I'd like you guys to draw them too on this one, okay? So start at the bottom one, and we're just going to kind of draw a longer line. Oops, undo. Didn't mean to do that. Hold on. There we go. Okay. Draw a little bit of a longer line. I'm going to make it a little bit thicker so it's easier to see.
Number 11, but you have to make this one louder.
Okay, so we have one long line drawn across. I'm going to draw one down now. Okay, notice how these 2 points cross? Where do they cross? 0, -3. So that's where one of our ordered pairs, our other, what are they called? Vertices of our square is going to be. And then we got to figure out where the other ones are going to be. So I'm going to draw up this time. So we have a line going up, and then this time a line going across. So basically we've drawn these 4 lines of our triangle, and we just need to figure out where they cross to figure out where our 2 other vertices go. You see how that works? Just draw your lines and figure out where the points cross. Is it super difficult?
You mean you draw those lines on that one?
Not necessarily, no.
We don't have to draw a line on that one?
No. Okay, I'm going to go ahead and move my dots. There we go. Oh, whoops, I made it really big. Undo.
That's how mine turned out. Copy and paste the normal.
All right.
Where we
So,
can go with the copy and paste on that one?
as long as you have dots, you're fine.
Oh, yeah, I did.
So one of our dots is at what ordered pair? One of our new ones.
0, -3.
Good. 0. So we went over 0, down 3. So 0, -3 is our first one. Oops. -3. And where does our other one end up? Good. -3, 0. We went backwards 3 first, and then up and down 0. So there's the other 2 vertices for our square. So it's just a lot of drawing, figuring out where the other ordered pairs are. Your answers are where are the ordered pairs. Up here, 0, -3, -3, 0. You write down the ordered pair. So you can, yeah, you can put the dots in the correct spots and then write down what the ordered pair is where you put them. Okay? Well, you could just wait for me and I will tell you instead of just skipping ahead. We'll get there when we get there. Okay? I'm going to go ahead and look at slide number 10 on this one. This one gives us all 4 ordered pairs. It says graph the ordered pairs 3, 0, -2, 0, 0, -3, and 3, -3 to form a quadrilateral. What is a quadrilateral?
A shape with 4 sides.
Good. A quadrilateral is a shape that has 4 sides. So once we connect all 4 sides, we just have to say what shape it has formed. So let's go plot those points on slide number 11. Our first one was 3, 0. So we start at 0, 0. We're going to go to the right 3, up or down 0. So we just leave it there. 3, 0. Okay, why don't you guys finish plotting those other 3 really quick? I'll give you about 2 minutes. Plot those other ones. Okay, plot those other 3 points, please. We're going to connect the lines on this one too, so draw some lines on there as well, please. Connect the dots. Are there more slides on it? Then no, it's not the last one. Okay, so our other ordered pairs, our next one is -2, 0, so that one goes right here. Okay. 0, -3 goes down here. And 3, -3 goes here. So we have this weird looking shape of things. I'm going to draw the lines and connect them really quick. Oh, whoops. Undo.
Do we draw the lines on this one too?
Yes, please.
Yeah.
Okay.
Thank you. So I'm going to get these lines all connected, make them a little bit thicker so they're easier to see. And then we have this shape. There is a name to this shape. We have not necessarily talked too much about it yet, but we are going to in the next couple weeks for sure talk about this shape. So let's. You did not learn it in kindergarten. Maybe like third. Okay. Give you guys another minute to just finish putting those points on and connecting the lines, please. Check your ordered pairs then. 3, -3. Okay, it's looking like a lot of you guys are getting close to finishing it, so I'll give you another minute. -2, 0, -3, 0, 3, -3, and 0. Number 9.
Yeah.
0, -3, and -3, 0. Okay. 4 units. All right. Let's go ahead and answer number 11 here. Once you connect the lines, we need to talk about what shape is formed. This is a quadrilateral. Quad means 4. So that means it is a 4-sided shape. It's not a square. A square would have all equal sides. Not a rectangle because it would have parallel sides. So what is this?
It's a quadrilateral.
Well, we know it's a quadrilateral. What type of quadrilateral? What's it called?
Trapezoid.
It's a trapezoid.
Yeah, it's not because they have only 2 parallel lines.
Good. It has 2 parallel lines. So this is called a trapezoid. Okay. We are going to learn more about trapezoids because we're going to start finding the area of different shapes soon. And trapezoids are one of the ones we're going to talk about a lot. Okay. Trapezoid. Trapezoid. When you say it over and over and over again, it does sound very weird. All right. And we have 1 or 2 slides left to do. So slide number 12. This is kind of where what we talked about yesterday comes into play, where we need to find the distance when it's a half a mile on the grid. So it says, using the map to answer the questions, the coordinates are represented on the grid with a unit of 1/2 of a mile. So if you move 1 unit, you've walked half of a mile. If you move 2 units on this grid, you've walked a full mile. 3 units is 1.5 miles. Okay, so each unit represents 1/2 of a mile. We need to find the distance from the park to the school. So if we look here, we have the park up at the top, and then we need to walk to the school, so that's down. We first need to figure out how many units it is. What's the distance from the park to the school?
5.
5. It's 5 units. Wow, it's so little. Hang on. So let me make this like, is 24 enough? Nope. So 5 units times 1/2 of a mile, so 1/2 equals. We need to figure out what 5 units times 1/2 of a mile to see how far apart the park and the school are. What is 5 times 1/2? It is 2.5. You guys remember how to find that? You could either,
5 under 1.
Do you simplify?
yeah, simplify. So you would get 5 over 2, which ends up being 2.5 miles. Okay. So 5 units times a half of a mile means that you are going to have to walk 2.5 miles to get from the park to the school. Okay. All right. Our next one says, if the coordinates representing the library, the park, and the mall were connected, what polygon, so what shape are we going to form? Elijah? It is not a rectangle. What is it asking you? Oh, I think it's a rectangle. A right triangle?
No.
Hang on, let me just make this a little bit wider. Stop it. There we go. So the park, the library, and the mall, it's not necessarily a right triangle, but it is a triangle.
Triangle?
It's just a triangle, right? Because if we were to draw the lines, I'm just going to do it. You guys do not need to. From the park to the mall, or and the library.
Oh, never mind.
And then our next one goes from the library to the park. Can you wait until we're done just in case you did something wrong so that you know? Yeah. So if you were to connect the points from the library to the park to the mall, it is a triangle. Not necessarily a right triangle because it doesn't form a right angle anywhere, but it is still a triangle. Triangle. Okay, and then our last question there. What is the distance from the library to the park? So we need to do some counting across. I'm going to make this a little bit bigger. What is the distance from the library to the park? How many units?
It'd be about 6 units.
It is good. 6 units times, how much does each unit represent? How much of a mile? Half of a mile. Yes.
This is kind of like dividing like rows.
You are dividing, yep. So what is 6 times 1/2, or 6 divided by 2? 6 times 1/2.
3 miles. 3 miles. 3 miles.
Good. It's going to be a 3-mile walk from the library to the park.
3 miles.
Okay. Good. Good. It looks like you guys are keeping up really well. Awesome. We have one last slide to do here. Okay, guys, voices off. We're almost done. Let's finish it up. I'm going to go ahead and go to slide 13. We have 5 questions to do. We've done this a lot of times lately, okay? I'm going to write it on a piece of paper so you guys can find me on your Google Meets or on in person. You can look at me. But I'm going to write on a piece of paper for the answers today because I don't want to move over to the whiteboard. No, we're going to do them together. So our directions here say the blue house is located at 4, -1. The red house is located at -3, -1. The green house is located at -3, 2. And the yellow house is located at 4, 2. We need to find the distance 4 times. So first, what is the distance from the green house to the yellow house?
7.
So we have green and yellow. First of all, what is the coordinates of the greenhouse? -3, 2.
Can I just put 7 units on it?
Sure, but let's do the problem still. What is the what is the coordinates of the yellow house?
4, 2.
4, 2. So if you're looking at my screen in the corner, we have, there we go, the green house and the yellow house. We need to talk about find the distance without plotting the points. So when I look at these ordered pairs, what do I need to do? We look for the ones that are the same. So what numbers are the same here? The 2's, right? So we're going to cross out the 2's. And we're going to use the -3 and the 4. What do I do with those numbers? Add them. We got to find the absolute value first to make them both positive, right? So the absolute value of -3 plus the absolute value of 4 becomes 3 plus 4, which, as like 8 of you guys have said, is 7. But is it just 7? What's going to 7 units? Good.
Units.
Good. So the distance from the greenhouse to the yellow house is
I mean, these inequalities, these
7 units.
inequalities will still have variables in them, and you're gonna solve them almost like an equation.
Say that again?
So the equation has an equal sign and it has a less than and greater than. There you go. Good job, Emily.
It depends on how far apart your blocks are. So let's say this is 7 blocks away, but if the block is like 10 feet, it's not like you're walking that far. But if each block is a mile long and you're walking 7 miles from the greenhouse to the yellow house, that might not be very much fun, right? All right. Why don't you guys take 3 or 4 minutes and work on number 2, 3, and 4. You can also do 5. So how do you find the distance without graphing? Yeah, however you do it, yeah. So work on 2, 3, and 4, and 5, please. Yes, turn it in. Okay, so go ahead and work on those ones. We will review the answers before, so if you want to wait for the answers, that's fine. But work on 2, 3, 4, and 5. I just need the answer. I don't need to see your work. Yeah, as you finish, you can turn it in. If you want to wait to make sure your answers are correct, that is fine too. But you're completing numbers 2, 3, 4, and 5, please. Okay, about 1 more minute, because I think you guys have gotten pretty good at finding the distance. So.
Miss Jones, I'm done.
Okay, once you're done, you can get it turned in. And then we have science at 12:30.
Okay, bye.
Bye. All right, let's go ahead and go over the answers really quick. What did you guys get for number 2? What's the distance between the blue and the red? 7 units again? All right. And what about the distance from yellow to blue?
3 units.
3 units. Good. And green to red?
3 units.
Also 3 units. What kind of shape would this make then if 2 sides are the same and 2 sides are the same?
It'd be like a trapezoid.
Nope, not trapezoid.
Triangle?
Nope.
Square?
Nope.
Rectangle?
It's a rectangle.
Rectangular joint with 2
All right. And then number 5, explain how you would find the distance. What do you do?
count.
You can count, but we don't have a graph to count it on. So how do we do it without the graph?
Add.
Add what?
The numbers.
Well, which numbers?
Dot point.
Well, yes, but what specific ones? What are you looking for?
I don't know.
I mean, you're on the right track, but how do you know which ones to add together?
The ones that are not the same.
Good. Add together the numbers in the coordinates that are not the same. Good. Okay, I'll give you guys a couple minutes to get that typed out. As you guys finish up, you can get it turned in. I'm going to go ahead and stop our recording here.